Hello and welcome to tonight's Frosty Drew Live. We are still kind of getting set up. Daylight savings, of course, causes problems because it means we're an hour earlier. So this is really 6:30 a week ago. So the sun set was a half hour ago, and we're just starting to see stars come out. I think we're going to have the moon for you at first because that's something that we can do right now. And then we'll see as the night progresses if we can start to do some other things when the skies get a little darker. We are planning for an hour tonight, and we hope to hold to that. So we'll see what happens. All right. I think we're going to start with Scott since he has the moon all lined up, and then I'm going to continue finishing setting up my telescope. Scott's still muted. Maybe he's not ready. So the other thing we want to try to show you tonight is more of the galaxies in the Virgo supercluster, some of the ones that are a little bit more interesting and show some details in their interactions. So hopefully that will be interesting later tonight once it gets dark.
I got a quick adjustment to make, and then we'll be good to go.
Oh, excellent, Carlin.
Yeah, it's nice, isn't it?
Yeah. It's good.
It's New England people.
Never know what's going to happen in Frosty Drew.
All right, 1 second.
It looks like it's starting to get a little darker there now.
Yeah. Yep, I'm starting to see stars through my my camera here.
Okay, so I'm going to share my my app. Okay, so this here is the moon. My image is a little small right now. We'll see if I can't figure that out as the night goes on. But tonight we're looking at the 44% waxing crescent moon. And in this view here, the moon is actually upside down. And that's a product of my telescope mount, the way everything is lined up in the sky, the way the camera's attached to it. I'll be right back with that. Everything is lined up in the sky, the way the camera's attached to it. There we go. Somebody's got the YouTube stream playing out loud. All right. And when we talk about waxing crescent, we're talking about phase progression here. So when you think about the moon and the way our view works of the moon from Earth, the moon is orbiting Earth. It takes about 23.7 days to make one full orbit around the Earth. But that's not the same as the phase cycle, which is what we call the synodic period, which is 29.5 days. And that's because we're also orbiting the sun. And sunlight cast on the moon plays a really big role in what we're seeing. So when you think about the lunar cycle, so last Saturday we had the new moon. And on the new moon, that means the moon is right in between the Earth and the sun. And the side of the moon that we see is completely in nighttime because the opposite side of the moon has all the sunlight in it because that's what's facing the sun. And we also don't see it at all, not just because of that, but also because it follows the sun across the sky. So it's out for the entire daytime period. Now that the moon has moved past that position, now the moon orbits Earth in a prograde motion, which is counterclockwise. It is now moving leftward from the sun if you were looking at the Earth from the top down. And we're starting to see some of that side of the moon that is in direct sunlight, with still more of the night side in our view. So when we say waxing, it means that the moon is getting larger or more illuminated from our point of view per night. And when we say crescent, we mean that it's less than half full. The opposite of a crescent is a gibbous, which is when you have more than a half moon, and you can see the moon approaching the full moon, which is completely full. Now, it's important to note that the full moon happens when the moon is on the opposite side of Earth than the sun, and sunlight shines past the Earth, and we see the entire side that's illuminated, with the nighttime side being on the opposite side of us. Now, I'm going to zoom in on a couple features here if I can.
So you weren't sharing, Scott, so I threw up my image of the moon so people had that to look at.
Yeah, I thank you, Derek. I really appreciate that. Is this live?
This is as live as I can do with the bandwidth that I have.
If you want, I could throw my image back up. I could definitely do that. I forgot to reshare, because I'm great like that. I moved the moon out of my field too, so give me 1 second here. Try to get it back in.
While Scott's doing that, I'll talk to you real quick about some of the details that we can see in the image that I have here. One of the three big features to look at is obviously the illuminated side of the moon, which we see as the left in this image. And then the right side we see is dark, and it is in shadow. And then the line between those two is called the terminator. And right at the terminator is where the shadows are very, very, very long. Think about like if you go for a walk near sunset or sunrise, your shadow casts way, way out on the ground. And the same thing's going on right there at the terminator. So when you look at the craters along that area of the moon, you see some really nice deep shadows in the craters that allow you to kind of get a feel for how tall the crater walls are and some of the shape of the crater walls, but you can see it in the shadow. I'm going to take another picture with a longer exposure, and we'll actually start to see some of the left side is going to be completely blown out, but we'll be able to see some of the other parts of the moon that are currently in shadow. But what illuminates that part of the moon is actually the reflection of light from Earth coming back to us after it bounces off the moon. So it's going from the sun to the moon and back. And you can start to see, a little bit of the features there on the right side with, now that I've taken a picture that's, let's go a little longer and see if that helps bring out a little bit more detail. But eventually it just blows out and the whole camera can't handle it. But I think that's kind of a neat phenomena if you think about the light bouncing from Earth to the moon and back to us. And then we see that, and we call that Earth shine that we're seeing on that part of the moon. And similar to what Scott was saying, this image is inverted from what you'd see in the sky. Right now, if you're looking up at the moon, the sky, the right half of the moon is illuminated. So, all right. You good, Scott?
Almost. What's up? Yeah, I'm losing my zoom in view. Give me 1
I was going to say, if anyone watching has any moon questions.
There we go. I got it back. So you guys ready?
Sure. I'll stop sharing.
Now that I got a view, I can try to focus this too. All right, here we go. All right, you guys see this?
It's loading. Yes, we can see that.
Great. Let me get my focuser here, and we can try to get a little bit of a focus going on this thing. It's shaking around a little bit. Sorry about that. And let's see what we can do here from there we go. It's a little bit cleaner right there. All right, so what we're looking at here, this here is Marea Serenitatis, also known as the Sea of Serenity. And just below it here, we have Marea Tranquillitatis, which is the Sea of Tranquility. Now, the Apollo landing site is roughly right over in this region right here. That's where the Apollo 11 mission landed. And you notice that there is a difference in the the tone of grays between these two regions. And that's because this region of Maria Tranquillitatis has a substantially higher amount of titanium distributed across this area, and it creates that bit of a darker glow. It reflects a little less sunlight than the surrounding basalt or lava bed that we see here. Now we notice that there's a lot of really great cratering here. As Derek was describing, these craters are quite notable because they're along the lunar terminator. But overall, most of these craters are rather insignificant craters. And they just look really great because the lunar terrain, the surface of the moon, is extremely rigorous. And when you look out in this area over here to the left, which is rather overexposed right now, you don't really notice that because you're looking more in direct sunlight. But when you look at the side of the moon that is right where that sunset line is, what happens is sunlight shines across the surface. It's kind of like it does here on Earth. Think about sunset, and the sun is out blinding you while you're driving, and all your shadows are super long behind you. Same thing on the moon. Those really long shadows that get cast, that gives you depth of field and allows you to get an accurate view of the rigorous lunar terrain. So we always try to be focusing our telescopes on, or somewhere at least near, that lunar terminator. Now, if you take a look down at the bottom here, and I'll increase the exposure just a little bit, you'll notice that you have some bright dots right here over the nighttime area. And what's happening is these are crater rims that stand so high off the lunar surface that even though the edge of the moon isn't in sunlight, those mountains are high enough, those crater rims are high enough that they're actually catching just a little bit of sunlight. I mean, when we talk about moons and cratering on the moon, we're talking about mountains that are the size of like the Rockies. I mean, these are some serious craters. Now, another thing we're going to see out here tonight. So I'm at Frosty Drew right now. We have a series of visitors that are out. Some of them keep stopping by to take a look. And it's a crystal clear night out here, and the wind is dying down. So we're really rocking socks tonight. But we're about to see the International Space Station pass in about 7 minutes. And that applies to all of you guys as well. If you're in the Northeast, anywhere, within the next 5 to 10 minutes, you'll see the ISS passing by. And tonight is a fabulous pass. It's going to pass over our region at about 71 degrees up. So it's practically overhead. And it's going to be bright. I mean, we're talking bright, like airplane bright. And this is, I call these family-friendly ISS passes because they're happening at roughly 7:50 at night during a period that, all the kids are still up, everyone's still doing their thing. We just finished up dinner. So it's a good time to get the family out and take a look. So I'm not going to be able to put the telescope on it tonight because I don't have the tracking software loaded. And I don't know about Derek, but I don't think he will either. Nope. But what I would suggest is just to step outside during that time frame. Well, I'll let you know when to go outside. And that, you got to do is look up and look for the object that's moving across the sky like an airplane that doesn't blink.
You said at 7:50-ish?
Yeah, so 7:50. It's like 7:51 for this location. So roughly, it depends on where you are. If you're anywhere in southern New England, 7:51. If you're outside of that, add or subtract about a minute until you're out of the Northeast area. Now, what I'm going to do is I'm going to crank up my exposure a little bit more because tonight we have something called Earthshine. And when you look at the shadow side of the moon tonight, you can actually see it. So I'm going to see if we can capture that in the telescope by cranking up our exposure. There we go. So now we have the Crescent area is completely overexposed. This is an artifact of the telescope I'm using. It's called Chromatic Aberration. And right here, we can see the nighttime side of the moon as well. I'm going to zoom out. And with it zoomed out, you can see the entire night side of the moon alongside the bright area. And this is quite interesting because what we're seeing here is sunlight that reflects off of the Earth and onto the moon. and it illuminates it. So let's think about this for a minute. I mean, you can take my word for it, but you can also kind of play this out in your mind. So think about those nights here where you have like a 90% gibbous moon, you know, about 3 days from the full moon. And that moon is up and it is bright. The whole landscape around you is lit up. You can see in the dark and everything in the sky is washed out. But if you were on the moon on that night, looking back at Earth, what you would see is just a 10% crescent Earth. And you would see the nighttime side of Earth illuminated because of all that moonlight you see around you on the ground shining back off, because all the moonlight, all that sunlight reflecting off the moon is hitting the Earth and brightening it up. So the same thing happens alternatively when we have a crescent moon. If you're on the moon tonight, you have roughly a 56% gibbous moon, or gibbous Earth, I'm sorry. And it's casting a lot of light onto the lunar surface and light and brightening up the ground around you if you were there. And we can see that shining back at us, and we call that Earth shine. Tonight's probably the last night we'll see it, because once, even though it's always there, once we get into first quarter, which is a half moon, one, this is going to overpower our view of this. And second, the less light is making it to that side of the moon at the same time. But I'm going to zoom back in real quick, and I'm going to try to move this around a little bit because we have another really great object in view tonight, and I want to see if I can capture it real fast. So let me move the telescope itself, because tonight we have a conjunction happening. A conjunction is when objects in the sky that move, sometimes two objects, end up close enough to each other that they stand out. And when you guys look up into the sky tonight, you actually can see several stars around the moon, but just to the right of the moon, there's a rather bright star just sitting right there. Kind of red, and that's not a star at all. That's actually Mars. Let's see if I can swing over to it in here. I'm going to put my exposure up a little bit higher, see if we can get it. And what's interesting about seeing Mars in here tonight is not only is Mars in the view, but on the opposite side, you have Aldebaran, which is a red giant star. And it looks like Mars. So at this point, it's kind of hard to tell which is which unless you really kind of know. So let's see if we can get it here. I'm going to speed up my motion just a little bit.
Scott, while you're moving over to Mars, we have a question from the chat from Tim, and he's asking, what if we witnessed an impact live, like from the moon?
That would be awesome if we saw that. But something to consider. What impacts on the moon don't happen the way they used to. So when you're thinking of impacts, you're thinking of, you know, these big craters we see. We call them ray craters, like Tycho crater and Copernicus crater and all these really big craters. But unfortunately, we really don't see those types of impacts happen in modern times. And that's because the solar system is not as active, so to speak. All of the very large objects that were part of planetary formation in this orbit, there it is right there, that's Mars, that were in this orbit have all been either collected as part of the moon and Earth or ejected out to the scattered disk with everything else. So as a result, the only thing that really hits the moon these days is really small meteorites. A lot of them, about 100 tons per day. But those small meteorites, instead of leaving impact craters and flashes, they just kind of chisel away at all the craters that are there and flatten them out. So unfortunately, we really don't see that anymore.
And we on Earth, I'll try to jump in there, Scott, but we on Earth also experience that type of bombardment, but our atmosphere protects us by creating friction for those objects and causing them to basically be destroyed. And we see those as meteors streaking through the sky.
Now, there was a couple, I think there's been, correct me if I'm wrong, Derek, but I think there's been 2 impacts or flashes that have been captured in recorded history, and neither of them left an impact crater that we were ever able to find. So if we saw one happen tonight, you would see like a really quick blip in our view. It would be so Go ahead, Derek.
I was going to say the last one I know about was during the 2019 eclipse in January of 2019, and they used like a probe that was in orbit of the moon to go like resurvey the area from where the flash was, and there was no discernible crater to pick up. So it's kind of interesting how such like that you could see the results of the impact from Earth as a flash, but the results of the long-term results being a crater were never evident, which is kind of interesting. Very small.
But I would love it if we saw an impact. And I was angry that we missed it that night when we were out with the eclipse, because we were watching the moon the entire time and we totally missed it. So if you have do you have something, Derek?
I just have another picture of the moon. I switched over to using my guide scope as my imaging scope so I could get the full moon.
All right, so I'm going to disconnect. I'm going to stay on, but I'm going to be showing the ISS to our visitors.
Okay.
And I will let everyone listening know when's the best time to go out and actually check out the ISS.
I was going to say it's 7:52.
So you want me to leave my mic on? You want me to mute?
Yeah, go ahead and leave it on. We'll see what you guys come up with.
All right, guys. So everyone here is standing around, and everyone who can hear my voice, if you guys take a look up in the sky out here, you'll see a little kind of star that's moving. And what we're looking at here is the International Space Station. Now, the International Space Station is going to pass almost directly overhead tonight. And this is humanity's only continuously inhabited space-based residency. There are people currently living on that station. The station orbits Earth at a rate of 17,500 miles per hour. So it completes one full orbit every 90 minutes. And that means they experience sunrise or sunset every 45 minutes. Now, when we look at the station in the sky, we don't see light being emitted from the station's labs or lights. What we're looking at is sunlight that's reflecting off of the station's labs and panels. And to see the ISS, the observer, us down here on Earth, needs to be in sunlight or in nighttime while the station itself is in sunlight. And all of you guys that are listening online, now is a good time to go outside and take a look. And you want to look up towards the south. And that's my ISS alarm going off. So as it gets higher, it's going to get brighter. And we may see it fade out when it starts to set. And that's because the ISS is going to drop into her shadow. We call this orbital sunset. And during that moment, everyone on the ISS is experiencing sunset. So you guys over there with Mike, the ISS is passing. This up here is the International Space Station. Now, something to think about with the ISS that's really important to note is when you look at the astronauts and all the passengers on board the ISS, you think to yourself that they must not be in gravity because they're floating around. But that's not true. You think about, the moon is in Earth's gravity, and the moon is 230,000 miles away. The ISS is only 200 miles up. What's happening, though, is gravity is not weight-centric. And what that means is that in a vacuum, if you drop a bowling ball and a feather, they'll fall at the same weight as far as gravity goes. So what happens on the station is the station slowly is falling back to Earth. At 17,500 miles per hour, it's quite close to escape velocity, which is 25,000 miles per hour. But all of those astronauts are falling at the same rate as the station. So they are suspended and experience weightlessness. So next time someone tells you there's no gravity on a space station, be like, that's lies. Like, don't give me fake news.
If there was no gravity on the space station, they wouldn't stay in orbit.
Exactly, right. They wouldn't have to be moving so quickly.
Yes. You can think of the space station as falling around the Earth fast enough to miss.
That's a good view tonight. That's beautiful. You guys all seeing this, the space station? You know, I see a lot of kids over here. All of you guys could work up there. And that would be a pretty cool job, huh? Imagine that commute.
So for those of you that are still watching the live view and haven't stepped outside, you're seeing a picture of the Pleiades, and then the picture behind that is a picture of the moon. See if we can. The Pleiades is quite close to the moon tonight. It's kind of nice with the if you go outside and you look, you can see the moon, you can see Mars to the right of the moon, where Scott was talking about it, and then a little bit below or a little further to the right and down is the Messier object known as the Pleiades, which is a very close open star cluster. It has about, I don't know, 40 to 50 stars, maybe 100 stars associated with this cluster. And we see it, or I see it, as a little fuzzy spot in the sky. People with better eyes can actually resolve the individual stars. And there are 7 that are, easily discernible naked eye. And a fun fact about the Pleiades is it's also used in the car industry as the Subaru logo. But they only use 6 stars in the Subaru logo. Go figure.
They're always missing the mark.
Something's got to be missing. Let's see.
When Scott was talking about the ISS there, I went over to the side of the house that's south facing, and I was able to see it right out of the window. It was super bright tonight.
Yeah, pretty cool. I think I have too many trees in the south of my house. All right. So while we are still in this area of the sky, let's go over to Orion and check out Orion's nebula. So this is a star-forming region that is in the constellation Orion. It's one of the closest ones to Earth, and it is one of the 2 naked eye star-forming areas in the night sky. This one is, if you know the 3 belt stars of Orion, it's just below the belt stars, and it's usually called out as Orion's sword, but it never focuses to a star. There are enough stars in the area that you would see individual stars, but there's also quite a bit of light coming from the nebula that is it's diffuse, so it doesn't really focus down to a point. And then the other naked eye visible star-forming region is the Lagoon Nebula, which we see during the summer, and that one is in the constellation of Sagittarius. All right, let's see if we can line this up. Sorry, I had to play with my exposures to get the moon to look right, and it's making the star exposures for stars incorrect. The moon is quite bright, obviously, compared to the average star. So here we go.
I have a moon question for you, Derek. I don't know.
I might be able to answer it. Let's see.
So there are craters and there are mare. How were they formed differently? Like, why do they look different?
So that's a good question. Mare is the result of lunar volcanism. So long ago in the moon's life cycle, it had enough of a molten core that it had volcanism similar to what we have on Earth, but at kind of a broad, maybe a larger scale, because what would happen for some of the mare, it would be an impact itself would basically fill back in with the not quite solid inner core or inner material from the moon, and that's why we see that material looks like a little bit of a different color, because the surface has been grossly disturbed and mixed with the regions below the the top layer of the moon. In other places, it's kind of less distinguished because there have been more craters over the years that have kind of just merged together, or the craters have filled in and the mare kind of overflowed all of the craters and filled in other geographical features of the moon. For example, down here at the bottom, you can see that is basically circular. So that's a probable candidate for what would be an impact, and then it fills in when the mare cools, and then kind of above it, they're less detailed or less distinguished, but there's still some circular features here. So those are just older impacts, and then the ones like these three here, which are probably quite a bit newer, they just have the traditional crater with the floor being basically the same as the material around it, and then those potentially have a central peak, which is kind of a rebound event as the event of the impact kind of comes to an equilibrium.
Cool.
All right. Hopefully that was a good answer.
It definitely was.
I can try to elaborate if necessary. All right. So this next picture that's going to load is going to show up in this field here where the Pleiades currently is, and it's going to be the Orion Nebula. And you're also going to see a couple of other nebula in this field of view. I'm taking a little bit longer picture than I traditionally do for these events, just because I want to show some of the detail versus just kind of some of the brighter objects there. So I took a 30-second image, which is going to take another about 10 seconds.
I see Scott back over there with the red light.
I saw a red light.
If he's trying to get something live there too, or
we'll see.
Yeah, we'll see.
Still waiting.
And while you're finishing waiting for the Orion Nebula picture, Tim asked again, how long would it take to capture an exposure of Uranus tonight?
So the planets are quite bright. It wouldn't take long at all. When we image planets, we actually traditionally do video, because you're using a technique called lucky imaging, where you take thousands of images, at 30 frames, 60 frames a second, and you sort through them, and you sort them for roundness among other traits, and you take and cull the ones that just don't look like anything remotely like a planet. Because what ends up happening with the light from a planet and light from stars is Earth's atmosphere distorts the light as it travels through the atmosphere. And that's because of temperature layers, that's because of humidity, that's because of any multitude of atmospheric details. And Neptune and Uranus in particular are the two outermost planets. And even at a very high magnification, you're only going to get a very small disk for the planet. So you kind of have to use that technique to get enough data to make an image. Visually, it's bizarre that just the way it works, the human brain and eye make it so it doesn't look like that's happening under most conditions. There are certainly atmospheric conditions that are, you can look at, Jupiter, which is the largest planet, and it's like, yep, Jupiter's looking like a disco ball tonight, and it's just like not round, and then it'll be round, and then it'll be not round, and it's just all over the place. But for the smaller planet, or not smaller, I mean, Neptune and Uranus are certainly not small planets, but they're far away, so their angular diameter is quite small. And angular diameter is how much area they take up in the night sky from a perspective of Earth. Okay. So hopefully that answers your question. And And then I'm going to talk about this picture that was just loaded up during that answer. And we'll be looking, this is the Orion Nebula that we're looking at. And there's actually 3 nebula in this picture. And we'll talk about each of them. And they have their own. So the one here on the right, which is this large kind of like open cavern, that's the Orion Nebula. And inside of the nebula in the core, you've got the star-forming region, and that's what we see as the very bright area of the nebula. And everything around it is just other gas in that area that is also, part of that star-forming region, but it's just not dense enough to be actively forming stars at the moment. Over here, a little bit to the left, there's another nebula here, which is, I believe, a reflection nebula for this bright star here that we see. And you can see my computer telling me that that's M43. And then it might, I don't know if I get the mouse in the exact right spot. But then there's also this dark nebula that sits in front of it all. And what we're seeing there is a nebula that's closer to us than the Orion Nebula, and it's blocking the light. So we're basically seeing the shadow of that nebula. Think of like if you hold up a leaf to, like a lamp, you're going to see the backside of the leaf. And then in the upper right or upper left corner here, these stars are actually associated with another nebula, which is called, sometimes called the Running Man Nebula. No, we can tweak some of these. Yeah. I don't think I took a long enough picture to really get that nebula, but that one's pretty dim. But it's kind of neat because it has like it looks like a stick figure that's running. Is the best representation I can give to that verbally. And then right in the middle, down here in the Orion Nebula, is a really interesting star cluster. And I say interesting, but it's interesting from the point of view of being able to resolve it. And it's called the trapezium. And it's 4 stars that are extremely close together. And being able to resolve those stars individually means you have very good sky conditions. Photographically, especially with this configuration, I don't think I have enough pixels in this camera to pick them out individually, but nonetheless, they are there. And then another thing to talk about is the Orion Nebula. It goes, way off of this image. Like it goes. Let's drag this over. Like if you think about it, if you want to think about it, it goes quite a ways over here, and it's just quite dim in this area. But this whole area of the sky is just crazy active with different nebula and features that are going on. The left side of Orion, that from like its shoulder to his foot, is a giant arc of a nebula that's called Barnard's Loop. I don't have the field of view in any of my cameras that are set up tonight to be able to capture that, but you have to be able to capture like the entirety of the Orion constellation and quite a bit to the left of it as well. It's the Orion Molecular Cloud Complex is what the whole area is kind of called. So, any questions pop up, or do we want to see if Scott's got something, and I'll try to go find something else?
Yeah, I don't know. Scott, do you have anything live over there? I think he's showing somebody the live stream.
All right, we're gonna go slide over to the Beehive. Actually, let's stop here real quick and see if we can get the Horsehead and the Flame Nebula.
The Horsehead is one of my favorite to look at.
It's incredibly hard to get in a short photograph because of what type of nebula it's. Well, because it's like it's a dark nebula sitting against an emission nebula, and it's just super dim. Scott has changed.
Hey, it's James. Hi, James.
Hi. Hey guys, how's it going?
It's going good.
It is crystal clear out right now. It is absolutely
awesome.
beautiful.
Beautiful. So you've morphed into Scott, huh?
Yes, Scott stepped away, I think, to handle visitors in the observatory.
Cool.
It's actually quite busy down here. There's a decent amount of folks over here.
Cool.
Nice.
Good night.
So we also managed to switch up our target to the Pleiades, and we were able to capture a quick, like 30-second image.
Oh, nice.
So I guess at any point we can share our screen here again. Let's see.
Yeah, if you want to share that real quick and talk about the Pleiades, I'll finish lining up on this next thing and then jump into that discussion.
Yeah, perfect. Let's see here. Center window. And we want the dark table window. All right, are you guys seeing that?
We are.
We are.
Okay, perfect. The beautiful Pleiades, M45, Blue Reflection Nebula. This is a beautiful target, and we're actually, I guess, starting to lose it as we move into deeper into galaxy season. As the summer approaches, we're kind of watching this target fade into the west. You really can't miss it. To me, it tends to make out a small measuring cup, especially when it's orientated differently or early in the year.
Yep, I can see that.
You know, it's very, very hard to miss, and a lot of people refer to it as the Little Dipper, or should I say, mistake it with the Little Dipper.
Yeah, I've encountered that.
But the blue wispiness here is actually already starting to come to life, and that's the, if I'm not mistaken, Derek, you can correct me if I'm wrong, but that is the reflection nebula. That wispiness that's happening is being illuminated by local starlight.
Yep.
Yeah, so I mean, this makes this a fantastic target to look at, whether you're looking through binoculars, telescope, even just by eye. I mean, obviously by eye we wouldn't be able to make out the reflection nebula within it, but still a pretty target nonetheless to look at. I know Scott was trying to get Mars in the view. If I can happen to make that happen before this ends, that would be great. I would love to be able. I don't know if you guys have made it to that point.
Yeah, he was trying, and then I don't know what happened, but it's always a game.
Yeah, because it's in between going, I guess, fighting with this program and having the limited zoom, and then trying to actually slew to it with a very quick alignment.
Yep.
Well,
I got the flame and.
Well, it seems like someone has a question here too. Ken was asking the string of stars in the middle. What was that? He was asking.
In which object, please?
I think the one that James just had up.
Oops, I'm sorry.
If there it was not. I'm not exactly sure what he was asking, but it says, "What is the string of stars in the middle running from the top?" Maybe.
Oh, I see what he's talking about.
Those.
These guys here.
Yep.
Derek, I'll definitely let you handle that one.
I don't know that I have an exact answer, but I can generalize. With open clusters, the way that they are kind of the end stage of a star forming region. What's happened here is that the gas has formed stars, and enough stars is such that the gas has been blown away and is no longer present. So caveat with the Pleiades is the Pleiades are moving through a region of space that happens to contain some gas that is being illuminated by the stars. We know that the gas that is illuminated is different than the Pleiades because they have different relative motions and velocities. So they are not associated with each other over the long term. And what happens with open clusters is the stars are gravitationally interacting, and the stars get ejected, or they get ejected in pairs or in groups. I mean, sometimes maybe the situations are set up such that stars go through and they get ejected over time. And that might be why we're seeing, what looks like a chain of stars. I don't know. Again, it's a generalization. I would have to do some research to figure out if that's, remotely accurate. But it certainly seems plausible. We can ask Scott when he comes back. He knows a little bit more about a lot of the details about some of these objects than many of us do. Okay.
That is awesome though to even hear, and I guess I never even put that together. It's kind of cool how everybody's eye and brain interpret things differently. That's not the first thing that would stand out to my eye and brain, so that's really cool. I never saw that, and now I'm going to look for that every single time I look at this object.
And then another thing to note here is you're seeing purple stars because of the type of telescope. As Scott told us when we were looking at the moon, that purple halo is called chromatic aberration. So the telescope isn't perfectly focusing all wavelengths of light at the same point. Because wavelengths of light have different, oh dear, sorry, telemarketers.
It's okay.
Wavelengths of light, they're different frequencies, so when they pass through glass, they refract differently. And you can pair or group glass differently to, correct for those differences. And obviously, as you add more elements of glass, the weight goes up, the price goes up, and but visually, it might not be this bad because the camera has a different color palette than our eye does. Just something of note. Okay, so if you want to stop sharing, I can bring.
Did you get the horse head?
I'm going to take a longer picture while I'm talking and see if it pops up. Again, I'm not on my good camera tonight because we're doing wide field stuff. But we'll share this screen again, and we'll talk about what we can see here. Okay, so what we're looking at is a region of space just to the left of the left star in Orion's belt. So this is the really bright star. That's the left star in Orion's belt. That's Alnitak. So just to the left of that is this nebula here. And that is the Flame Nebula. And you can kind of see the flame is rooted here and kind of goes up through the nebula this way. So what we have is a dark nebula like we saw in the Orion Nebula in front of another nebula, and it just happens to have a little bit of a flame shape to it. So the horse head is theoretically right here. I'm going to take a longer picture and we're going to see what happens. What we're looking at here is 30 seconds. We'll go for a minute and see if that works out.
I'm glad that you pointed out the Flame Nebula there, because for my untrained eye with that, I thought it was a smudge.
Oh, yes.
And you pointed it out and I was just like, wow, no, there it is. That's so cool.
A lot of things in astronomy we do describe as either, it's the smudge that's brighter than the rest of the space around it. Actually, I think a satellite went through that picture. There's like a little streak in the bottom right. But there's a lot of satellites up there too that are fun to run into. But yeah, so the Flame Nebula in particular is quite dim, and you can see it with the telescope. But the Horsehead Nebula, there's no chance of seeing it with a telescope because it's against a wavelength of light that our eyes are not sensitive to, which is emitted by hydrogen gas, and it's in the infrared spectrum. Most cameras are still sensitive to that frequency of light or wavelength of light because the IR cut filter that's in cameras is not perfect. Just a little trivia. Let's see. We've got, all right. babbled long enough. The image is downloading. We'll see what happens. The Horsehead Nebula is even dimmer because of what type or how the object is structured. So we'll see if it pops up at all. Otherwise, we'll go check out a different object.
And while that's going on, Tim asked, I think it was technically Scott's software, but he asked, what's your software, or are you able to simulate chemical lines with your software, or do you need to actually have a spectroscope?
I can answer the first part of that question for both Scott and I. Scott uses a technique called tethered imaging, and he's using the program called Darktable, which is tethered to the camera to capture the images. In my setup, I'm using a program called K-Stars. Both of the programs are open source applications that are. Darktable is not specifically for astronomy, but it can be used for astronomy. And K-Stars is also a planetarium software. So the view that I'm looking at, I'll slide it over real quick just to show everybody, and I'll get these out of the way. So this is the view I'm looking at when navigating the telescope. So that image would be awesome if that just showed up in the camera. Like, that would be amazing. But that represents hours and hours and hours of research data that is in a catalog that K-Stars can pull from to project onto the digital sky that I have on my computer. So if we zoom out, you can see the constellation Orion. This is that Barnard's loop that I was talking about earlier. And then there's more hydrogen up here. This is the Orion Nebula down here. And then there's even another nebula up here that's pretty dim. Just another nebula in Orion. There's so much nebulosity around Orion that it's crazy. And then earlier tonight we were over here with the Moon, the Mars, and then the Pleiades is right there. So as far as the spectrograph part of the question, I've never done anything with spectroscopy, I think is how you pronounce that. Anyway, not my field, and haven't gotten into this. This for me is mostly a hobby, so haven't really jumped into that part of astronomy in my hobby. I'm not sure if Scott would have additional information to offer, so we can ask when he goes back. James, I assume, because you do most of your photography work as well.
Yeah, it'd be the same for me. Unfortunately, it would have to be something for Scott. But I mean, I just wanted to say real quick about the K-Stars program that you're using. That just looks extremely, what's the word I'm looking for? Useful.
I used to use a different program, and I started using K-Stars about a year ago, and it has blown my mind as far as how well it works. I used to have 3 different programs, and they were all barely working together. And this is just everything works in one program.
That's what I need, yeah, because I'm kind of in the same boat. I'm using so many different things. It would just be nice just to have one, and that looks very detailed as well too. A lot of the ones that I'm using really aren't the most detailed.
Yeah, I mean, it is a little bit of a resource hog when you have this turned on, but you can turn it off and not have the sky survey as part of the background image.
Right.
Yeah. So the next thing we're going to go jump over to is another open cluster. This one's in the constellation Cancer, and this one's called the Beehive. I don't know, James, if you haven't found Mars, your telescope has a little bit wider field of view. It might be interesting.
I could definitely get over there. The Beehive or Mars? I'm sorry. Beehive. Okay. I'll tell you what. I'm just gonna throw myself on mute for a second. I'll definitely try to get it in.
And Derek, someone else had a question too. It said, how are dark nebula detected? It would seem more likely for us to miss them since they don't emit or transmit light.
Absolutely. And they, for a long time, were not known. And there's the dark nebula that I've shown tonight are the ones that are obvious because they have a broad light producing region behind them. Some of the other dark nebulae that are not obvious are the ones that only have stars behind them. So, you know, sometimes the starlight does get through the nebula and it doesn't get, you know, consumed by the nebula, but we still can see some of it. In the early, I'm going to get the dates wrong on this, but anyway, in the last like 100 years, we were able to, radio astronomy is not affected by the dust that these dark nebula are formed from, dust and gas. So we were able to realize that like the galactic plane is basically just all dust at different densities, but it is basically all dust. And when you look towards the constellation Sagittarius, you're looking into the like core of the galaxy, but what you can't see is past the core, because the core is dense enough to basically block out the things that are on the other side of it. There's enough dust there, just in general, you can't see past it. And with radio astronomy, we were able to, for the first time, peer beyond the galactic core, and start to make measurements for that part of the galaxy that had really never been observed through visual astronomy. Yeah, I think we'll leave it there and see if there's a follow-up. All right. So we're over here, and let's see if we can get a quick lineup on the Beehive, and then we'll show you guys a picture of that. And then we're coming up on our end here, so we might end with the Beehive. So the Beehive is in the constellation of Cancer, right in the middle. All that's, yeah, landed on it perfectly. Excellent. All right, so while this image is capturing, I'll show you guys in this program where Cancer is. So Cancer is basically an upside down Y, and it's, if you know where Leo is, it's the constellation ahead of Leo, and if you know where like Castor and Pollux are in Gemini, they kind of point down towards Cancer if you follow them south. Cancer is mostly made up of very dim stars, so it's not a super obvious constellation. But if you know what to look for, you'll see this like fuzzy patch, which is the Beehive. And you can kind of see that it looks a lot like the Pleiades in that it's kind of a very big open cluster because it's close to us. And it has a similar density, but it doesn't have those like 6 or 7 super bright stars like the Pleiades does. It has quite a bit more, maybe almost 20 that are kind of equal magnitude. And this is M44, so we're counting down through the Messier list. Orion was M42 and M43, so we did 4 in a row tonight. Not in sequence, but you've got 4 done there. So we'll see if Scott's back. I don't know if he has any last remarks.
I'm not sure if they have their headphones
on. Yeah. So some notes about next week. It'll be close to a full moon, which kind of drowns out a lot of what's in the sky. And then the week after that, we start to lose the moon again, but it won't be completely out of the sky. So we'll see if we have enough to put a program together for next week. If we do something, it might be one of our non-live, just show you some things that we've found over the past, and some pictures that have been captured by the team. But other than that, I think hopefully everybody had a little fun tonight, and I appreciate everybody who tunes in, and hopefully this summer we'll be able to see everybody come out to Frosty Drew and hang out with us in person.
Live, for real.
Live.
Yeah. Looks like James is back there too for a minute.
Yeah, I was
Yeah.
gonna say, guys. I was able to get it. It was really quick, and Scott came over at the last second, and we were able to get it perfect. If you guys just want to check it out
Yeah.
real quick.
Because it should be a bigger field of view. We'll check that out real quick, and then we'll sign off.
All right, let's get it over here. I did a nice 30-second exposure just to show some of the eye candy there. We are still seeing a lot of the CA, but if you guys can see it there, it's
Oh yeah.
beautiful.
Yeah.
And it is crystal clear out right now. There's not even a trace of a cloud in the sky right now.
That's awesome.
And I guess the whole weekend is supposed to be like that too. So this is just amazing. We have, I'm not sure if you guys talked or mentioned it earlier in the live stream here, but we have the SpaceX launch happening. I guess, what is it? Sunday morning, technically? Or
There's another one Sunday morning. There was one last week Sunday morning. It was ridiculous.
So I was down real quick. I was down in Assateague Island in Maryland. And at that point, I was just delirious out of my mind from shooting Milky Way really late. And all of a sudden, I see what I thought was like a missile going through the sky.
Basically is. Yeah, we had finished up a Messier marathon. It was about 6 of us out at the observatory. And we were like, what is that? And then it just, but it was really, really cool. So you never know what you're going to see when you go out observing. So
that's the beauty of it.
Yep. All right. Well, thanks everyone for joining us tonight. We enjoy doing this, and hopefully everybody finds this a little bit of fun. And we'll post about next week in the coming days, and we'll see you for the next one, whenever that happens to be. All right. Have a good one, everybody.
Keep looking up.
Good night.
Clear skies. Nice.